How are you, everybody who is watching this fantastic video? Very happy to have you today. My name is Olenjolai TAYAI. Simply just call me Sir Olenjolai. I come from Tanzania. I'm living in this beautiful country, and this is our national flag. So if you love our country, then wave like this one, because you know this is the beautiful country where God lives. I'm very happy to have you, whether you're a national or international viewer. I would like to welcome you into these fantastic online institutions where we have a good news we prepared for you in order to transform you from the present state to the next state. I would like to take this opportunity and welcome you into our online Diploma Polytechnic Institute of Tanzania square bracket Olenjolai. Simultaneously, I would like to welcome you into one of our YouTube channels that's called the Online Diploma Polyinstitute of Tanzania square bracket Olenjolai. Remember that this is the combinations of the two words. Poly means that Poly Institute, the Polytechnic Institute. We produced a one word that called it Poly, so 4 letters of this word, and Institute, these are the 6 letters of the word Institute. So we are very happy to have you today, and we'd like to take you from one step to another step. So before we go into too much details, I would like just to give you a brief introductions on what are we doing. Well, we have an assignment to teach and train some group of students who will be ready to extract knowledge and wisdom from the formal and informal classroom instruction in order to combine with the wisdoms and knowledge from the Word of God in order to solve real-life problems. So our main objectives in this in online Diploma Polytechnic Institute of Tanzania is actual that to train our students on how they can use effectively the relevant informations we are teaching them and even that they used to learn in the class in order to solve real-life problems. Because we are going to schools or we are going to institutions or to colleges or universities in order to get knowledge that will help us to solve our real-life problems. So you're not going there to get certificates. Certificates are just certifications on a particular knowledge that you've achieved in a specified time, maybe 4 years, 3 years, or maybe more than 5 years. Okay, so that's the point that we like just to let you know. And again, before we go into too much details, we have also an online library where that we have some contents or some materials we like to equip our online students in order for them to go further, even further from the point where we teach them physically or we teach them online. So one of the resources that we have is textbooks. Okay, so when you want to master basic engineering mathematics or basic scientific mathematics, you need some books, and we recommend these books that we call Pure Mathematics 1 and Pure Mathematics 2. And also other reference books might be effective or might be help you on understanding the concept that you have to cover as ordinary diploma student. So you can order this book, just go to the descriptions in this video, and then you see the link of the video that will take you into the details or into the costing of these books that you have to order, and then that you can, yes, just you can deliver. We can ship it into any regions of 31 regions of Tanzania. So just order it. We are not doing the business. Actually, we are servicing you. So we'd like you to equip, and then so you can do more questions as well as you can in order for you to master the concept and apply it in different fields of engineering and science. So that's one of the announcements. Another announcement again is we'd like to ask you that, because we know possibly that you want to be means you want to join or to be the active member or the active student. Okay, active student, because this program is for teachers and also for students. Okay, for you to be an active student, we ask you that to click these buttons of subscribe, and then you find that its color, background color change, and the words also change into subscribe, and also the bell appear, and after the bell appear, when you click these bells, you will see 3 options. Just choose the options of all. So why should you subscribe? That's a good question. The reasons is actually we are here to solve your problems, because you've been wondering and you've been fearful that how you can master basic engineering mathematics or basic scientific mathematics. That might be a question in your mind. And we are here to try our level best to equip you and even to give you relevant materials that can help you to master, so you can be not fearful to fail your continuing assessment or your final exams. So you'll be competent enough and you'll have this subject of basic engineering and basic scientific mathematics for the rest of your life. So when you subscribe, you'll get notifications because we are going to have more than 300 videos in our YouTube channel. So this, once you click these buttons, you'll get official notifications once we upload a new video, because we'll be uploading at least one video every day in our YouTube channel. So stay connected and stay focused and you'll enjoy. Against that, maybe at the beginnings of these sessions or in the middle of these sessions or at the end of this lecture, you feel from your heart that you want to offer God your free willing thanksgiving for this program. And then God gave you instructions that to send in order to participate, in order to share the running cost for this program. So you can send your Thanksgiving offering, okay? So that telephone number 0759745331, right? And hence that your free willing Thanksgiving will be received with much thanks and will deliver, and yes, and then you'll get a feedback message because the registered name is Olenjolai TAYAI. You can also go to the descriptions below of this video, below of this video, and then you'll see in the descriptions the account number in case you want to do bank transactions. So we'd like to thank you in advance for what you are doing actually, because this program is expensive and actually that we are providing this content free as a chief of Tanzania. And I would like just to tell you that mathematics is universal. However, that we are going to focus on the syllabus and curriculums of the ordinary diploma in Tanzania, useful in Tanzania. So we invite you actually to concentrate and focus. However, that this material can help any ordinary diploma students worldwide, in any continent, in any country. And tell me in the comment sections, please, that you enjoy this content from which institutions or college or university. Remember that we are focusing on the curriculums of NACTE, National Council for Technical Education in Tanzania, right? So tell me in the comment sections, please, you enjoy this content from which country. So just we don't have any quick review because for my students, they used to expect you to have quick review of quick review of lecture 3. So lecture 3, we have been discussing about another subtopic that called relationship between roots of polynomial function, or relationship between roots of quadratic function and the year coefficients. So that's what we've been discussing, and we've been solving problems and we've been expressing different issues. So just to remind you what we have added after that, we have said that we can form expression of roots of quadratic function. So these expressions, you can have alpha plus beta, let's say, square, then you have alpha square, beta square plus twice alpha beta. So if we make alpha square plus beta square, we've been asked in the subject, we'll take sum of the roots, which is alpha plus beta square minus twice alpha beta. So sum of the roots minus twice of the products of the roots. So that is. Again, remember that you've been using these equations that sum of the roots, okay, x plus what? So yes, something like this, is it minus? Yeah, and then we say that plus what is alpha beta, this is equal to 0. Okay? Is it clear? Let me check if it's correct or it's not correct. Yes, this is correct. Products of the roots is equal to 0. So this is again another famous equation. Okay? But again, we say plus sum of the roots is equal to negative b over a, and then products of the roots alpha times beta. This is equal to c over m. Right? So this is what we have been discussing, and we'll be finding the value of some variables, etc., etc., etc. So, ladies and gentlemen, today I would like to introduce to you a new subtopic. And this new subtopic is called divisions of polynomial function. And this is lecture 4, introductions of remainder into its subdivisions of introductions of remainder theorem. So we have something called the remainder theorem. So we have, whenever you hear that we have something called the remainder theorem, then we have to expect ourselves that we have to expect ourselves that something we are going to solve a particular problem. So first of all, let me present to you contents of reminder theorem. What are we going to cover in this subtopic? So basically we are going to cover the following concept: introductions of reminder theorem. So we say this is 3.1 or 3.21. So I'm going to teach about introductions of reminder theorem. Introductions of reminder theorem. Then the next step we say that reminder theorems of linear reminder theorem. Okay, then I'm going to teach about reminder theorem. This is today's lecture. Reminder theorem of linear. So reminder theorem of linear divisor. Reminder theorem of linear divisor. That's what we are going to cover today. Then the next concept that I'm going to teach you, I'm going to teach you about the reminder theorem of quadratic function. 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 And then we go for the next step. Then we go for reminder theorem. Reminder theorem of cubic function. Reminder theorem of cubic function. Okay, cubic function. So basically we are going to cover these four concepts. And then it's not long topic actually. It's not long subtopic, but it's short subtopic. Okay. Okay, so let us have the definition and then state the theorem and then see it is necessitated and then we continue. So let us begin with 3.21 introduction. Introductions of what? Of reminder theorem. Introductions of reminder theorem. Okay. The fundamental question one is, what is reminder theorem? What is reminder theorem? What is reminder in math? Not reminder theorem. What is reminder in mathematics? Pause the video and ask yourself that question. What is reminder in mathematics? What do you know in your mind? From all level, from A level knowledge. What is reminder in math? Because you have reminder maybe in normal English means something, reminding you of something, but in mathematics you have a little different meaning. So it's a reminder, so we say that in maths, in mathematics, it's a reminder the reminder is the amount left over after performing some computation. in algebra, of polynomials, so we say of polynomials, algebra of polynomials, remainder is a polynomial left over after dividing one polynomial by another. One polynomial by another polynomial. So in mathematics, the remainder is the amount left over after performing some computation. Or in algebra of polynomial, the remainder is a polynomial left over after dividing one polynomial by another polynomial. So it means that you find remainder in maths is actual something remaining after we divide something. For example, you have 21 mangoes, you divide to 5 children. Then every child will get what? 4 mangoes, but one mango will remain. So for instance, you have 21 mangoes, and then you divide it to what? Divide it to 4 children. Then you find that each children will have 4, and then so you have remainder of 1. So it means remainder in mathematics, whenever you hear, whether in basic engineering mathematics or in basic scientific mathematics, you should have in your mind that this is something remaining after division. So if you are talking about remainder of polynomial functions, means that this is the function which is remaining after taking one polynomial function dividing with another polynomial function. If you are talking about remainder of quadratic of trigonometrical function, then this is a remainder. It's a function which remains after taking a certain trigonometrical function of the highest degree or highest character divided by another trigonometrical function. If you are talking about a remainder for exponential function, this is the result, or it's something remaining after taking an exponential function divided with another exponential function. So that's all. That's the concept. It means something remaining after division. Okay? Something remaining after division. So the next question, as best technicians, we have to ask ourselves before we state the remainder theorem. Next question. Okay? Why do we need? First of all, let us take this remainder theorem and then we state its necessity. So the next question 2, state what? Now state the remainder theorem. State the remainder theorem. So we said that remainder theorem the theorem that is used to find a reminder when a polynomial function which we call the dividend, okay, is divided by another polynomial function, and this is divisor. So remainder theorem is the theorem that is used to find the remainder when a polynomial function which is dividend is divided by another polynomial function, which is called the divisor. Okay, that's the remainder theorem. Okay, so that's how. So remainder theorem is the theorem that is used to find the remainder when a polynomial function which is called the dividend is divided by another polynomial function. So simply, so it means that before even we deduce this theorem, because it's kind of the common theorem, we say that let us see this problem. Okay, let us see this problem 1. Why do we need remainder theorem? So simply we say that divide x cubic minus 3x squared plus 6x plus 5 by x minus 2. Divide x cubic minus 3x squared plus 6x plus 5 by x minus 2. Okay, solution. So we have what? So we have x minus 2 then there we have x cubed x cubed minus what? 3x squared, then plus what? Plus 6x, then plus what? Plus 5. So here we have x squared times x, so we divide, we find divisions of this. This makes x cubic, and this is minus 2x squared. So if you subtract, you get to it. Negative 3x minus negative 2x squared. This will make negative x squared, right? So negative x squared. So then we take here, we have plus 6x. Then we think that we take negative x squared plus 6x divided by x minus 2. So then we get what? Here it is minus x. So minus x times this one is minus x squared. And this one is what? It plus twice x. Then we say minus. So this is what? 4x. So 4x, then we have 5. So plus 5. So again we say that for this case, you say plus what? Plus 4. Okay? So 4 times x, this makes 4x. 4 times 2, this one is negative 8. 4 times 2 it is negative 8. So if you subtract, you get 0. 5 minus negative 8, this makes 13. Right? So from this division, we find that if we take x squared, x cubic minus 3x squared plus 6x plus 5 divided by what? By x minus 2, right? So then this is equal to x squared minus x plus 4, right? So then this is equal to what? This is equal to plus what? 13 of what? Over x minus 2. So this is the answer. Means if you take this over this, you get this one and you get this one. But what if you have maybe a polynomial functions of degree of 5, and then it's possible that here you have the cubic functions as a divisor? What do you expect? So you'll find that you are going to face so many challenges on that long division, so we call it that is long division approach. Okay, so that's not the effective method. Okay, you'll spend much time and sometimes you may even miss the right answer. Okay, so that's why that we need a reminder theorem, because reminder theorem simplifies what? The long division. So remember that this is all about what? Long division. Long division that we've been learning from primary school to ordinary secondary school. So this is about long division. So from here, it means that we can even also derive. It means that we can let these functions to be a certain function, this is another function, this is another function. But this is very important format of reminder theorem that we are going to do. So why reminder theorem? To solve the long Euclidean divisions of polynomials. So we go to the question. Why do we need reminder theorem? Why do we need reminder theorem? This one is to solve a long Euclidean problem. Solve the long Euclidean problem. To solve the long Euclidean problem of polynomial. So that's why we need the reminder theorem, to solve the long Euclidean problem of what? Of polynomial. But the reasons that we need it. Okay. So then we want now to reduce, because we have long gradients. Okay, so let us go to the next part, derivation. Derivation of reminder theorem. Derivation of reminder theorem. Derivation of reminder theorem. So I say that from problem 1 above, so we say that from problem 1 above. So ladies and gentlemen, right now let's welcome you into the next part, because we know the answer why do we need the reminder theorem to solve the long Euclidean problems of the polynomial function in simplified, okay, in simple way. So in simple way. So it means that reminder theorem simplified the long divisions, the long division. So the derivations of reminder theorem, okay, from the problem 1 above, let x cubic minus 3x squared plus 6x plus 5 to be f of x. And then, so it means that we want to derive the reminder theorems because you see that this is kind of a simple divisions of polynomial function. What if now you have a functions of degree of 7 and here maybe you have a functions of degree of 5. So it might be actually tedious for you to go through the long divisions like that. So we need a theorem. That's why we have derived that theorem that's called reminder theorem. So from problem 1 above, so we got the solution. We let these functions in the numerator to be what f of x, which we call numerator, and x minus 2 to be g of x, which is denominator. However, that this we call the divisor, this we call the dividend, and this is divisor, this is quotient, and this is remainder. Okay. So again, we say that let this reminder that x squared minus what? Minus x plus 4, right? To be what? To be q of x. Then again, let 13 to be reminder. So to be reminder r of x, right? So it means that right now. Okay, so we say that after we let all of this function f of x, g of x, q of x, r of x, then we can restore the values into this solution, okay, to the divisions and solution. So on the left hand side we have f of x, which is equivalent to this function, and then in the denominator we have g of x, which is equivalent to x minus 2. Then this is equal to q of x. So q of x is what? X squared minus x plus what? Plus 4. This one plus r of x over what? Over g of x. R of x it is what? It's 13. And then g of x it is x minus what? Minus 2. So again, dividend over divisor, right? Dividend over divisor. So this is dividend over divisor is equal to quotient plus what is remainder over divisor. So dividend is this one. Divisor is this one, this is quotient, this is remainder, and this is what is divisor. Okay? So whether you use these equations or this equation to deduce the remainder theorem, then you'll find that everything is okay. So you may use either of the two formulas, either of the two forms, because they have the same meaning, but you want you to enjoy the bit of basic engineering mathematics and basic scientific mathematics. Tell me in the comment section, please, if you have any question. Please ask in the comment section. Alright? So, if we consider this f of x over g of x, this is equal to q of x plus what? Plus r of what? Plus r of x over g of x. Okay? So, if you multiply, so you say that, let's say for instance, because this is the first step, and the second step, say that multiply by g of x to both sides. So to multiply it, we have what? The g of x multiplied by f of x over g of x. This is equal to what? Q of x times g of x plus what? R of x over g of x times g of x. Right? So if that's the case, we have the function f of x is equal to q of x, then multiplied by g of x plus what? Remainder r of x times g of x. So if it's the case, you say that this is f of x, then this is equal to what? G of x, G of x, Q of x, G of x plus what? R of x, G of x. Okay. So this is the case. So that is the one of the format of the function. So because we are looking for the remainder theorem, no. So this one and this one will cancel. It's just like this one and this one will cancel. So this is wrong. Okay. So to make the remainder, to get a remainder from this formula, we can make R of x the subject. This is equal to f of x minus q of x times g of x. So this is a remainder theorem. This is general formula of remainder theorem, right? Remainder theorem. So in terms of what? Of dividend, we say that remainder, this is equal to what? F of x is equivalent to dividend minus what? Q of x is what? Quotient, and then multiplied by what? Divisor. So the general form of remainder theorem is that. So with this general form of remainder theorem, you can find remainder theorem of all this, of any function with divisor, with linear divisor or quadratic divisor or polynomial divisor or cubic divisor. So we say that the general formula of what? Of remainder theorem is given as what? As this one. R of x is equal to what? Is equal to f of x minus what? Q of x times what? G of x. But this is condition that f of x should be, remember that the condition is f of x should be, must be higher degree. Higher degree than what? Okay, so let me write wow. So we said that the general form of remainder theorem is remainder is equal to f of x minus q of x times g of x. Okay? G of x. So this is if the dividend is highest degree of what? Of divisor and quotient. Highest degree of what? Of q of x and the g of x. That's the condition. But through this formula, we can determine remainder of any divisions of polynomial function for any given divisor. Okay? So if you want to write in this form, we say that every remainder is equal to dividend minus, or in other words, in terms of economics, say that the remainder is equal to what? Is equal to dividend minus what? Quotient times what? Divisor. Quotient times what? Times divisor. So that is. Okay, so that's the formula that you have to deal with. So let me teach you about remainder theorem. As I promised you, remainder theorem of linear divisor. Remainder theorem of linear divisor. Okay? Remainder theorem of linear divisor. So he said that if the linear from the general formula of remainder theorem from the general formula of remainder theorem, which is R of x is equal to f of x minus q of x times q of x. Okay? We say that if g of x is a linear function, g of x is a linear function, if g of x is a linear function such as a of x plus or minus b, a of x plus or minus what p, then the divisor now, okay, the divisor, which is equal to g of x, will be equal to a of x plus or minus b. That's the general form of 40 of remainder of 40 of linear function. So therefore, the remainder for this case, which will be a constant value, is equal to f of x minus q of x, and then instead of g of x, now we have what? A of x plus or minus b. So this is a general formula of remainder theorem with linearity linear factor. So ax plus, so this will be given, this will be given, this won't be given, but it will cancel because that if we do substitution, we find that this will become 0, this won't be given, in some cases it will be given. So it depends to the type of the question, right? So you should have this in your mind, that this remainder is equal to dividend minus what? Product between the quotient and the divisor. Okay, quotient to dot and the divisor. But remember that for this case, f of x should be highest degree than x, q of x and the x power 1. Okay, so if that's the case, it's the time right now. I would like to spend some time for this lecture 4 to solve problems. So example, and this is example 12. So let us do some questions quickly, and then I leave the homework to be the end of this lecture. Find the reminder theory. Find the reminder when x cubic minus twice x squared plus 6 is divided by remainder by x plus array, then hence use remainder theorem. Do you enjoy the beauty of basic engineering mathematics? Do you enjoy the beauty of basic scientific mathematics? Tell me in the comment section, please. So find the remainder of it. Find the remainder when x cubic minus twice x squared plus 6 is divided by x plus what? Plus 3. Hence, use the remainder theorem. Solution. So to use this remainder theorem, we have to, first of all, we have the first step, we have to follow some few steps on solving it. So check or classify plus 5 the divisor. Classify the divisor. So to classify the divisor, I say that it is linear. It is linear. So our divisor x plus 3 is linear because the degree is what? Is 1. So it is what? It is linear, which is x plus 3. Okay? So when it is linear, then we'll be recalling this formula. When the divisor is quadratic, we have to modify this formula. And when the divisor is cubic, we have to modify this formula also. Okay? So the second step, let the divisor, which is equal to what? G of x naught, which is equal to x plus 3 is equal to 0. So x plus 3 is equal to what? To 0. So make x the subject. So x is equal to negative 3. So suppose that this is question 1. We need this. Because remember that if we have the remainder, or we obtain the remainder, this quotient or these linear functions will become 0 when we substitute the value of x. So x is equal to negative 3. Okay, that's the second step. The third step, you have to recall the formula. So third step, you have to recall what? The remainder theorem, the formula of remainder theorem. Form of remainder theorem. Yeah, have to recall the form of remainder theorem with linear divisor. linear divisor. And this is what? R of x is equal to what? F of x minus what? Q of x multiplied by what? A of x plus or minus B. Right? So what is R of x? R of x, or reminder. So a reminder function R of x is equal to f of x. What is f of x? So we say R of x is equal to f of x minus what? Quotient of x. Then here, say we have ax plus or minus b. Okay? So we have to let f of x is equal to the given polynomial function, which is x cubic minus what? Minus twice x squared plus 6. And then we say that ax plus or minus or plus what? Plus b, this will be equal to x plus 3. So if that's the case, we say that the remainder will be equal to f of x, which is x cubic minus twice x squared plus 6. And this is minus. Okay? We don't know the value of this quotient, which is q of x. And then we say that with this one, we have x plus 3. Okay? So this is equation 2. That is equation 2. So this is first step. The first step, we say that substitute equation 2. No, substitute equation 1 into equation 2. So to substitute it, we have R of x is equal to what? What is x? X is negative 3 power 3 minus 2 negative 3 squared plus 6. Then minus q of x, then times what? Negative 3 plus 3. Then this is R of x. Then this will make what? Negative 3 times negative 3 times negative 3. This will make negative 27. Then negative 3 square, this will make 9. 9 times this one will make 18 plus 6. Then minus what? So here we have q of x multiplied by 0. Okay? So remainder of this function will be equal to what? So here we have negative what? Negative 12. So it will be negative 39. Okay? So ladies and gentlemen, we'll be asked to find the remainder. So it's a remainder for this case is negative 39. You are done. Wonderful. I believe that you're enjoying the beauty of watching the beauty of basic engineering mathematics and basic scientific mathematics. So, ladies and gentlemen, example 13. So this is conceptual question. It's one of the interesting questions. Find the value of h find the value of h given that when the polynomial function f of x is equal to what? Twice x cubic plus 3x squared plus h of x plus 2 is divided by x minus 1. The remainder is 4. Remainder is 4. Solution. Find the value of h given that when the polynomial function f of x is equal to 2x cubic plus 3x squared plus h of x plus 2 is divided by x minus 1, the remainder is 4. Fantastic. So we given what? Dividend and the divisor, and also remainder. But in dividend, we have been not given. We haven't been given one of the term, which is actually that the third term from left to right. So that the problem that now we have to solve. So it's still all about division, but we are focusing on what is remained after the long divisions, or divisions between the dividend and divisor. So find the value of h given that the polynomial function when the polynomial given that, so this is, we have comma, given that the polynomial function f of x is 2x cubic plus 3x squared plus h of x plus 2 is divided by x minus 1, the remainder is 4. Right? So solution, you have to follow the same step. First step, plus 5 plus 5 the divisor, plus 5 the divisor. So the divisor, and this divisor is what? The divisor is x minus 1. Plus 5 the divisor x minus 1. So to classify the divisor x minus 1, this we say what? Classify the divisor x minus 1. So it is what? It is linear divisor. So because it is linear divisor, then we go for the second step. The second step, we have to recall what? We have to let the divisor is equal to what? Let the divisor is equal to x plus 3. No, x minus 1. X minus 1. Let the divisor to be equal to what? X minus 1. X minus 1, divisor is equal to x minus 1 is equal to 0. So solve for x. So x minus 1 is equal to 0 and x is equal to positive 1. This is equation 1. Great. When we go for the third step, we say that recall, reminder theorem, recall reminder theorem with linear divisor. With linear divisor. Okay? So recall the remainder theorem with linear divisor. We say that this is R of x is equal to f of x minus what? Product between quotient, and then we say that we have ax plus or minus b, like this. Okay? So, again, we have to let now. Let reminder is equal to 4, we've been given. Let f of x is equal to 2x cubic plus 3x squared plus h of x plus 2. And also let what? Let ax minus b is equal to x minus 1. Alright? So afterward, you can pause the video and try that question, solve that question yourself, and then you check the video. Okay. So if it's the case, we say that on the left hand side we have 4, then our dividend is twice x cubic plus 3x squared plus h of x plus 2 plus what? Quotient, which is cube of x, times what? X minus 1. Right? So this is equation 2. Equation 2. Okay? So if this is the case, you say that we go for the fourth system. Substitute equation 1 into equation 2. So what is question 1? Question 1 is x is equal to 1. 4 is equal to twice 1 cubic plus 3 1 square plus h of x plus 2. Then plus what? Plus cube of x 1 minus 1. And this is 4, 2 plus 3 plus h of x plus this one. And this is cube of x multiplied by 0. So this is what? Minus 7. H of x plus what? Plus 0. So this is negative 3 is equal to h of x. So therefore, the value of h is negative 3. Value of h is negative 3. So that the response. Value of h is negative 3. Value of h is negative 3. Okay? So let me solve a conceptual question. Then leave the homework for you. Let me solve another conceptual question, which will be example 14. And this is come from the past paper, one of the past paper. composed at the Islam Institute of Technology. It was final exams or university exams of 2017. So this is example 14. So first of all, this concept, and then we have to refer the Dar es Salaam Institute of Technology final exam or university exam or UE, whatever they call it, of the year 2017, NK level 4, and this is question 1. Question 1E. Question 1E. So the question said that the remainder theorem, the remainder obtained when a polynomial function or polynomial p of x is equal to twice x cubic plus k x squared or x cubic plus k x squared, then minus 6x plus 1 is divided by x plus 2 is 2 times what? The remainder. Two times the remainder when the same polynomial is divided by x minus 1, find the value of k. Find the value of k. And this is 4 marks. So that's the concept. The remainder obtained when a polynomial p of x is equal to 2x cubic plus k x squared minus 6x plus 1 is divided by x plus 2 is 2 times the remainder when the same polynomial function is divided by x minus 1. Find the value of k. So we have one dividend, which is what? 2x squared, p of x is equal to 2x cubic plus kx squared minus 6x plus 1. And then we have been given two divisors. One divisor is x plus 2, another divisor is x minus 1, right? So we have been given one dividend. This is the dividend, p of x to x. This is descriptions of the question. 2x cubic plus kx squared minus 6x plus 1. We'll be given two divisors. One divisor is what? X plus 2. And another divisor is x minus 1. So when we take the dividend, p of x is equal to 2x cubic plus x squared minus 6x plus 1, we divide with the first divisor, which is x plus 2, then we get a certain remainder, right? Which is unknown also. But when also we take the dividend p of x is 2x cubic plus x squared minus 6x plus 1 and divide with the second divisor, which is x minus 1, we get again another remainder. So again, these two reminders have been compared by the compose of the question and found that the remainder we get when we take the dividend and divide the first divisor is 2 times The remainder, when we take the same dividend divided by second divisor, we have to find the value of k. 1. It seems like a confusing question, but it's very interesting questions in actual reality. It's testing you about your comprehensions on algebra, because that's what happens in life. Sometimes that what you are looking for is given, so you have to find what it cost you to get what you have in your hand. So solution. So solution say that the remainder obtained when this one. So when you say, so the first step, you say that classify what? Always you have to classify the divisors. So both divisors are what? Both divisors, when you say divisors, are linear. So if they're linear, then we have to be careful, right? So we go for the second step. The second step, let the first divisor, which is x plus 2, to be equal to 0. So this is equal to x minus 2. If you make x the subject. Again, let the second divisor, this is divisor 2, divisor 1, divisor 2, x minus 1, this is equal to 0. And this implies that x is equal to what? X is equal to 1. So we can put these divisors in form of the equation. So we have the first divisor is x is equal to negative 2, and the second divisor is x is equal to what? Positive 1. So x is equal to negative 2, and so x is equal to negative 2. This is first equation. Also we have x is equal to positive 1. This is second equation, because we need them, right? So you have the same dividend. So the third step, so that we call remainder theorem. Call the remainder theorem. So the step we say that we call the remainder theorem. So the remainder theorem, we say that we have what? R of x. This is equal to what? F of x minus quotient, which is cube of x, then times what? Times ax plus minus b. Okay? So we have our dividend. Huh? So, say that for the first divisor, you have to let what? The first divisor, you have to let r of x to be r1. So then we say that this is r1 is equal to what? F of x. F of x minus what? Q of x and ax plus b. So again, you have to let a of x plus b to be equal to x plus 2. So you say that R1 is equal to dividend. Our dividend is twice x cubic, then plus what? Kx squared minus what? 6x plus 1. Right? Plus 1. And this one is minus what? Q of x. And then you say what? You have x plus 2. Okay? So we don't know the remainder yet. So this is equation what? This is equation 2. Question 3. Question 3. Remember that this is general question. This is question 3 and this is question 4. This is question 4. Okay? So to have this this process, we say that that's equation 4. Okay, so we say that we have to substitute. We have to go for the first state. So that we have to substitute equation what? Equation 1 into equation 4. So this is equal to R1 is equal to what? Is equal to negative 2. So 2, negative 2, 2 plus K. Then this is negative 2 square minus 6. This is negative 2 plus 1 minus what? Q of x. Then negative what? Negative 2 plus 2. So R1, this is equal to negative 2 times negative 2 times negative 2, which is negative 8. So this will make negative 16. So plus what? 4K. And this will make what? Plus 12. Plus 12. Then plus 1 minus 0. Right? So reminder 1. This will make what? Negative 16 plus 12 is negative 4. Plus 1 is negative 3. Plus 4K. This will make equation 5. That is 3 plus 4K. That's question 5. So then we have to define question 3. For the second divisor, so this is the fifth state. For the second divisor, we say that you have to let R of x to be R2, and you have to let A of x minus B, this is equal to x minus 1. So you have to substitute them. This is R2, then you have what? F of x2. This is suppose x1 is x2, then minus what? Minus Q of x, and this is what? X minus 1. So this is R2 is equal to what? Is equal to f of x2 minus what? Q of x, and this is x minus 1. Find that 2 is still unknown, but given polynomial function is twice x cubic plus what? Kx squared minus 6x plus 1. And this is minus what? Q of x. And here we have x minus 1. So this is question 6. So you go for the sixth state. sixth state, so that substitute equation 6 in equation 2 in equation 6. So in equation 6 or equation 5? Yes, in equation 6. So substitute it, we find that reminder 2, the value of x it is 1 cubic plus a 1 square minus 6 times 1 plus 1, and minus q of x, then times what? X it is what? X it is 1, so 1 minus 1. So reminder 2, this is equal to what? Twice plus what? K minus 6 plus 1 minus 0. So reminder 2 is equal to what? 3 minus equal to K minus 3. This is equation 7. Wonderful. You changed the beauty of best mathematics. So then we have equation 7 and we have equation 5. We have equation 5, we have equation 7. We have to come to the next condition. The remainder of obtained when a polynomial function, this one, is divided by this one, is 2 times the remainder when the same polynomial is divided by x minus 1. Find the value of k. Okay, find the value of what? Find the value of k. So means the remainder, so according to that conditions, remainder 1 is twice of remainder 2. So that's, ladies and gentlemen, will be the 7th step. So this 7th step, so the 7th step, we say that for today's questions, we find that remainder 1 is equal to twice remainder 2. So this is what? Equation 8. So we say that to get the value, substitute equation 5 and equation 7 into equation 8. Okay. So into the case, you say that R1, it is negative 3 plus what? Plus 4k. This is equal to twice. Then we have what? K minus 3. Is it correct? Yeah, K minus 3. So then this is negative 3 plus 4k is equal to twice k minus 6. Right? So negative 3 plus 4k, this is twice k minus 6. So we have 4k minus 2k is equal to negative 6 plus 3. So this is twice k is equal to what? So negative 60 plus that one is negative 3 over 2 over 2. So k is equal to negative 3 over 2. Right? Wonderful. So that's the value of k. So the value of k is negative 3 over 2. Negative 3 over 2. So then it's the time now for me to give you the homework and end this session. Homework is very simple, very simple. Homework, this is homework 4, and this example Example what? Example 15. And you have to refer. I took it in the book called the Pure 2. Pure 2. Find a reminder. Find a reminder when x power 5 minus 4x cubic plus twice x plus 3 is divided by what? By x minus 1. So find a reminder when x power 5 minus 4x cubic plus 2x plus 1 or plus 3 is divided by x minus 1. So make sure that you do that homework and submit your homework in the comment section. Okay? So this is the end of lecture 4 of polynomial function as one of the topic of algebra in the departments of basic engineering mathematics and basic scientific mathematics. I thank God who have created me in his own image and likeness, and I give him all the glory and all the honor for everything that he has done. And I thank God who have been with me in preparations and even at the time of teaching this program. And I thank God who have given you an opportunity to be with me and to join me. I invite you in the next sessions, which will be lecture 5, when I'll be teaching you about reminder theorem with quadratic and cubic divisors. So don't miss. Make sure that you remember to subscribe in case you feel from heart that you want to offer our God a free willing Thanksgiving offering. Then you have to make sure that you send it to that telephone number 0759 745331. So may God bless you and keep you safe until we meet in the next session. Don't miss. And make sure to share these contents with your colleagues, because the time right now for the light to be upon the mind of best technicians in Tanzania, in Africa, in Europe, in America, in Asia, and even also in Australia. So may God protect you and keep you safe in your basic technicians learning process for the rest of your life. And see you in the next session. This is Olenjolai from Tanzania. I love you so much.